Yes, thank you for the welcome for today. My name is Aiken Weber, and I'm here to talk about e-mobility today for you. And especially, we're going to talk about safety features that are fitted into the cars. And we're going to talk about some tools that we need to control these safety features. And yeah, let me begin first a little bit with the yeah, let's say the motivation of electric vehicles. Um, as you can see, more and more electric vehicles are, yeah, has been seen on the road today, and we see from 2017, 18, 19 here the statistic of registration of vehicles, and as we can see in 2020 and 21, the amount of electric vehicles raised very hard compared to the situation that we had before. Yeah, why is that like this? In Europe, it's easy because the European Union had the goal of 95 grams CO2 emissions per kilometer. And to reach this goal, at least the manufacturers was forced to bring more and more electric vehicles to the market. Um, yeah, it means even if this will not, maybe I don't have a glass ball, but if this vehicles or electric mobility will be changed again in the future with something else that can happen. We don't know, but at least all the cars that are registered till today and also in the near future, they will come long or short term in our workshops. And yeah, we have to handle those cars. So it doesn't matter. We think that the combustion engine at the point of today will end sometime. It's not sure, but the electromobility will not only come on, it's already there. So we have to deal with it. So when we say we have to deal with electric cars, it means first to see what is the big difference from a normal combustion car. The big difference is the storage of energy. As you can see here, I put some technologies, some different technologies of electric driven cars. And all of those technologies have the same, let's say, issue, because for us in the workshop, it's a kind of issue. They have the same technology fitted, which is a high voltage battery. And this high voltage battery need, yeah, let's say a special treatment. Um, Special treatment means that we have to be careful when we handle those cars, when we handle the battery, because we have now an electrical storage. And if I compare that with what we have before, like the fuel tank was easy to handle. We all know that on a fuel tank, we don't have to put some fire on, and we know how to treat it. But and we see, especially when it's full or when it's empty. And on the electric side, on the battery side, it's not even easy, because even when you say the car is empty, it means we have zero electricity to drive. It don't mean that the battery is empty. The battery is still charged and is still a kind of danger for the people working on the car. So that means, especially this, what I say now, what is coming now on the next sheets, especially for Germany, but at least this will surely happen maybe in this way or a little bit different way in other countries in the world as well. It means that we need a kind of qualification to work on these cars. And the first thing to do is to think about what we have to work on the car. So if we only drive the car, if we only yeah, let's say our driver, private or professional, we don't need to have any qualification. It means that we have the situation that here in Germany we say this is the level S, and the level S is the driver and the owner, and the only thing that they need to do is, yeah, read the manual. S means here, if I translate that more or less right, is like a sensibilized person, which means that this person knows where the battery is and that electricity can be somewhere dangerous. That's all. But as a professional, we need to ensure that we are qualified on 3 different levels. So we start with the level 1S, which is an electric authorized person. It means that someone who is qualified 1S is allowed to do general works on the car, but is not allowed at all to touch the electric system. That means I can change tires, I can do some body work and stuff like that for sure. But once I have to touch parts of the high voltage system, or even cables from the high voltage system, I'm not allowed to do that. So if I want to work on the high voltage system, or even treat this, it means to set the system on safe. It means disconnect the high voltage. I have to be certified as 2S in a 2S level. This is a skilled person for work on high voltage system in a de-energized state. It means I'm allowed now to de-energize, to disconnect the high voltage system and to work on disconnected parts, even if they are high voltage parts. But they have to be disconnected before. And the next level in Germany, the highest level is 3S. And 3S is a person who is allowed to work at least also under tension. So it means we can do some diagnosis on the electrical system without shutting down the electrical system. That's the highest level that you can reach actually in Germany. The difference between 2S and 3S, it's very easy. As I already said, is the one is working under tension, the one is working by disconnected systems. But as well, if I talk about changing a battery, if I want to change the battery, I always need to have a 3S level, because the battery, as I said before, is never empty. So this is it's impossible to disconnect the battery itself. So we always have to ensure that we are on the highest certification to be able to change a high voltage battery. Okay. The time requirement, this is only for Germany and as well. If I want to make level 1S, which means I don't have the authorization to touch the electrical system, it means I need just a kind of short, let's say, training, which has a duration of 45 minutes. The next steps are way more complicated, or let's say more time working. So we have to use for the 2S 2 days training, which has at least 8 units of practice, which means almost the half time is practical training, how to disconnect the different ways the electrical systems on the cars. We're going to see a few of them. At least this is not the, let's say, I'm not 100% sure if tomorrow there will not be something else, because this technical world is turning very, very fast. And we see now different ways to shut down the electric systems that we have already, that we didn't see 5 years ago. But on this, we will come later for that. So once I have the 2S situation in Germany, I can sign in for the 3S level, and this means additional 3 days of training. And here the training is consists of how to dismount the battery, how to open the battery, making diagnosis on batteries and stuff like that. So this is a very practical training, which has 2 of the 3 days is practical and 1 day is theory. So if we compare a little bit the high voltage system with the general electric, means the house electric that we have at home, we see, because first I have to say, electric is nothing new. We all know that. We have a current at home, we have light at home, everything is working pretty much on the same functions. The thing is that an electrician that comes to you at home, he has different levels of possibilities. So when they're talking about touch tension, they mean 50 volt AC or 120 volt DC. Up to 1000 volt AC, 1500 volt DC, they talk about low tension. And everything what is going beyond is high tension for them. So they can make like trainings to have 20,000 volt at least, no problem, or even more. If we compare that with the car electric, it means for us that we are talking about low voltage, up unto 18 volt. Then we are talking about medium voltage, up to 25 volt AC and 60 volt DC. And high voltage systems are between 25 volt and 60 volt and 1000 volt and 1500 volt. As you can see here, where the home electricians start with the high tension, we already stop with the high voltage. This is not, and it will not be possible in the future to have more than 1000 volt AC on the car or 1500 volt DC. Because this was a kind of deal that we have between normal electrics and car electric. The deal is that they don't touch cars and we don't go over 1000 volt. It's very easy, because if we didn't have this deal, at least every electrician at home would be able to repair cars. Especially this is something that we don't want, because we are the car specialists and they are home electric specialists. So what you can see here as well is that we are talking from we have two different wordings. We talk about tension when we talk about the General Electric at home, and we talk about voltage when we talk from cars. This is especially done because we want to have if you read a manual, for example, and you see that they are talking about tension, then you know that this manual is talking about General Electric at home, and or building electric, let's say. And if you see that they talk about voltage, which is pretty much the same, we all know this, but if they write about voltage, they mean the cars. And if you see, for example, let's say a magazine with publicity of tools, and they write about voltage in the tools, then they talk about the electric tools for vehicles. And if it's about tension, then it's for the homework. Yeah, sorry. The high voltage here in our field is orange. And this is something special as well, because this never happened before, but all the automotive industry was said that all the cables and every relation that we have between high voltage components will be with orange color. I mean, all the cables are orange colored. And this is something that you will find in European cars, in American cars, in Chinese cars, Japanese cars, wherever over the world. And you see that, for example, here we have those kind of cables. All cables are orange. These are kind of special cables. And we have a double isolation here on this cable. Especially we have as well, if the cables are fitted from outside some parts, and they are, let's say, there is the possibility to reach the connector from outside the car. They are fixed by screw or by some click systems, so you can't take them off by, let's say, unfortunate. It means that this kind of special cables are completely secured, that no one can take them off if it's not allowed for him. I told you about double insulation on these cables. This means that we have at the inside the current line, which is a metal line. Around this we have isolation. Then we have again metal, kind of metal web, which is turned around the full cable from one connector side to the other one. We're gonna see later why this has happened. And around this we have an isolation again. That means, at least, if you have a cable which is damaged, which is just cutted, or there are some scratches in or whatever, this cable cannot be repaired. You always have to change the full harness. The full harness means all the parts that are connected with this cable situation. Yes, so this is something that I think in the future will happen more or less often, because we all know that this is kind of caoutchouc around. The isolation is a caoutchouc isolation. And we all know what happened after a few years in a special condition. And so if the cable becomes older and older, they are not smooth anymore. So it means that if someone moved them just a little around, it can be that the isolation already gonna be damaged, and at this place in the future, we will surely change more or less a few of those harness again. Yes. So let's compare a bit what we have outside in the cars already until today. I told you we don't have more. We are not allowed to have more than 1000 volt on the system. That means today we run two different voltage levels. We have one time the 400 volt systems, which is mounted on the most of smaller cars, and we have the 800 volt systems actually. And let's see a bit why this happened. The difference in the systems is now calculated for 200 kilowatt. We have an engine with 200 kilowatt, which is, let's say, a normal range engine. If we take this formula and its power, it means intensity by tension. And if we do the calculation with the 200,000 watts, we have 500 ampere of intention in the system. If we do the same calculation with 800 volts now, by 200,000 watts, we have 250 ampere on our system. Now we can say, okay, that's good, because we have the possibility to use by a higher voltage, to use smaller cable diameters or something like that. But this is not the reason. At the end, the reason is very simple. It's only the power loss which is counting. In an average electrical system of an BAV vehicle, you have a resistance, average resistance of 0.05 ohms in the system. And if you take this 0.05 ohm in a 200 kilowatt car, you will use this formula. So we calculated already E, and we use that 400 volt car means P 0.05 ohm multiplied by 500 ampere in square. We have 12,500 watt of power loss. It means the engine, instead of 200 kilowatt, has only 188 kilowatt, something like that. That's not big difference. That's not a big deal. Let's see how it is when we use the 800 volt system. We go down of 3.125 kilowatt. The difference is not very big here. So for a 200 kilowatt engine or car, this will not have a big effect for, I would say, if we talk about 9 kilowatts here, something, or 8 kilowatts, something like that. But let's see which vehicles are fitted with 800 volt technology. These are especially vehicles with much more power. Here, the example Porsche Taycan, which has 560 kilowatt of maximum power. And if we do the same calculations again, we first see if we to calculate E, which is here 1400 amperes, and that's very, very high rate of ampere. And we calculate the same thing with 800 volt, we still have a high rate of ampere, but it's only 700. So now let's see what happened with the power loss. The power loss by 400 volt would be 98 kilowatt. And 98 kilowatt for a sports car with 560 kilowatt means that the car has only 460 kilowatt. This is something that Porsche drivers, or I mean driver of sports car in general, will not accept. So for those cars, we need to go with the 800 volt system, and we still have 24 kilowatt of loss. But let's say we cannot get them disappeared because we have this 0.05 ohm resistance in the system, but we can explain that this is not possible to do it on a different way. So the maximum we can do is to increase the voltage to decrease at least the power loss until 24,500 watt. If we go now to see the danger of electric current, oh, sorry, I see it's written in German here. I have to change that one. The danger of electric current, what does it mean for us? Our body has a resistance of, let's say, in average of 1000 ohm, 1 kilo ohm. And if we take a tension from about 50 volt and we go with the formula E is U by divided by R, means that we have 50 milliampere of intensity on our body if we go for a shortcut with a body resistance of 1000 ohm by 50 volt. 50 milliampere, and we see before we had 700 amperes, so we see here a very big gap. And if we check the effects of it, we have this is something you can find very official. This is nothing that we invented for the cars, for electrical vehicle. That's something that is really coming from, let's say General Electrics. And we see in the zone 1, which is the green zone, on the left side we have DC, on the right side we have AC. And the difference is only the touching time, as you can see on the vertical column on the left side and on the right side. This is the touching time. And the green zone is something that you won't feel. If you touch the green zone, the electric is not, the current is not high enough, the intensity, sorry, is not high enough to make you any issues or even any feelings. That means, for example, if you touch the 12-volt battery of a vehicle, you will even not feel it. In the yellow zone, you will feel the current passing through your body. It means that this will not be nice, but it will not hurt you. Maybe the one or other has getting some electric currents already at the doctor, and they are using up to maybe 50 milliamperes. And by 50 milliamperes, you see we are on the second third of the range of the yellow zone. If you come into the orange zone, this is a zone that you already has some hurtings, but no damage, no big damage that will stay for long term. But if you reach zone 4, and we are talking here about a half of an ampere, 500 milliampere, we reach this zone, this can have some issues on your body. That means longer term health issues, or if you go more and more up, for sure, you even can die for it. So we say on 0.5 ampere, it starts to be very dangerous for a human body. And if you see that we talked about 700 amperes before, this is something, I don't want to try. And to show you what means to have 5000 ampere, and this is 5 times more than we have in a Tesla. If you see what happened with 5000 ampere, or it don't work, I will not believe. I tried that before with the other setup, it was working. I'm so sorry, guys. Something I will explain you. As you can see here, a metal plate on the right side of this, on the left side from this mannequin. And this metal plate, once we have 400 volts, 5000 ampere for 1.2 seconds ignition on it, the metal plate will almost disappear. It will be melting. And what happened with this dummy? It will get a lot of fire, so it means heat. He will get a lot of how to say that? Ultraviolet rays. It means also what is affected from the same thing that you have when you weld something, and it is absolutely mandatory with this kind of intensity, even with 1000 ampere below that, that we protect our body. And I'm talking about full protection here. I'm very sad that you can't see the video, because it's showing you how much this 1.2 seconds ignition affect the body of this mannequin here. To show you a little bit, what can happen on a human body. You will see here on this side, on this picture, that the hand of the guy who had a problem here was fully, let's say, it was a big thing for him, because he will not work anymore with his hand, I think. And you see, especially on the right side, on the right upper side, under the thumb, where the electricity went out again. It went out in through the fingers and out on the other side. So this is something that you want happen to you. Also here on this guy. Something what is important to tell you that in a normal workshop or workshop conditions on normal, let's say, mechanics, this will not happen to you until the safety systems of the safety features of the car are still in good conditions. This is something that can happen on a construction site or on the building site when you see where the cars are constructed. They are handling the batteries, the cables, and all those stuff without functioning of safety features. Means that they have to be very, very careful, and if not, you see the result here. They are having special workspace requirements, especially in the building of the cars. You see here, everything is in plastic or in rubber. So tools are completely mantled in plastic. The guys are using rubber gloves and much more. You see the floor here is a plastic floor and stuff like that. Everything for their own protection. But to be honest, for you in the workshop, this that's way too much. You can go very, very low on it. And the only thing you need is to wear a face mask. And here again, once again, sorry that you can't see the video, but you would see how this face mask will help to protect the skin on the face. Because if you do, you know the welding process. If you stay next to someone who is welding some metal parts, after a few seconds you will have red skin and you will burn your skin. And the same thing happened here. Unless that this one is much on a much higher intensity, so it means it's very more dangerous. So we need a face mask to protect our face skin. I always say use the helmet as well, because it's very nice to protect the face, but to lose all the hairs because they burn down. And as well, don't work in t-shirts. So use long arm shirts to protect the skin of your arms as well. And at least what you need for your personal protection is the only thing that is, or the most important thing for you is to wear those gloves. Now, the thing is, you don't need to wear those gloves for the whole working process that you have on this car. If you are a state S3 and you work under tension, then you need it, as you see on this guy on the picture. But if you are not working under tension, you only need to wear the gloves to disconnect the vehicle. So it means for a few seconds at least. This is nothing that you have to wear the whole day. As well for the protection mask. If you look in the workshop and you find out that you will need some minimum required workshop equipment as well, let's say the chains and the poles are maybe not something that you need, especially in the workshop in England, in Britain. Here in Germany, we need to ensure that no one who is not allowed can touch the car. It means we have to put chains and poles around the car to ensure that a mechanic which is not S2 or S3 certified is not able, he see that he has to cross this barrier before he can touch the car, and then it's his own fault at least. Something that you need, especially to disconnect the vehicle, is special tools, because we need here to work until the disconnection. We need to work on the, let's say, on the battery housing. And to ensure that nothing happens there, we use tools that are completely isolated. These tools are special proofed for isolation for 1500 volts. So there are no open metal parts on this kind of tools. And you see on the right corner, we have a measurement tool. This is, this tool is just showing you one of 3 tools that we need for the electric vehicles. We're going to talk about these tools a little bit more in detail, but we need to take care about the voltage level that we need to handle. As we see, we have 480 volts, 800 volts on the car. Sorry. If I have only 400 volt systems, I need tools up to maximum 600 volt. It's enough. But if I want to handle 800 volt cars with a 600 volt tool, I can't do it. So before I buy a tool, I need to know if I need 600 or 1000 volt. If I have the doubt that someone with 800 volt vehicle comes in my workshop, I prefer to buy only once than to use to spend a little bit more money and to buy straight 1000 volt tools, and to be sure that later I don't get any issues because of the malfunction of the tools on the car. Yeah, let's step a little bit more into the technical one, into the battery especially. We see here a prototype battery. The question you can ask me is why those guys are not wearing any gloves or mask. Very easy, because the battery is still not fitted on the car, and each of those power modules that you see here is under 60 volt. So they are not needed to use the gloves when they work in a condition like that. Once they fit the cable together, they have a high voltage battery block, and then they need to use gloves and shield for the face. The difference of the high voltage battery and the normal 12 volt battery is that we have now a lithium ion battery, and this Li-ion battery needs to be treated by a control unit. If you take a 12 volt battery and you put some more than 10 12 volt batteries in a row, it will work and it will increase the tension. But with the Li-ion battery, this is not possible, because every cell of this Li-ion battery need to be on the same level of intensity of current. Have the same current level. The difference that we will have, let's start like this. You see here different cells from left side to right side. They are put it into a stack, and from up to down, those stacks are put it together to a high voltage battery. And each cell which is fitted has 4.2 volt in the average, a full cell. It's pretty much the same that you have on your cell phone, on your smartphone. There is one cell inside which has around 4.2 volt. And if you put them together here in a module stack, or even in a battery, you need to ensure that all those cells, we are talking here by 96 by 74 cells, that all those cells has the same current level. If you are seeing I know especially for some Japanese cars, the maximum of cell current difference, which is allowed before they put the control light on your dash, is 100 millivolt, so 0.1 volt. If they are exceeding 0.1 volt, you got a warning lamp on your car, and you have to go to the workshop to see which cell is starting to get damaged. The thing is that to ensure that we are not exceeding this 0.1 volt, we are regulating the cells. It means that, let's say there is one cell in the old system that is decreasing the power level to 3.8 volt. The control unit will ensure that all the other cells get the same level. It means the battery becomes more and more ineffective at the end. The power of the battery decreases. And the customer will come to you and we say, okay, before I was driving 350 miles with one full charging battery, and now I drive only 280 miles with a full charge battery. This could happen that one cell is starting to get on a lower level, and the control unit just decrease the power of all the other cells as well. Talking about cells, how they are looking about. We have actually we have three types of cells. We have cylindrical cells that we use, for example, in the Tesla. We have those prismatic cells that is used, for example, in Volkswagen, BMW, and a lot of other ones. And we have Potch cells. Potch cells are used. This is a soft casing cell, and they are way bigger than the other ones. And they are used, for example, in Japanese electric vehicles. I know, for example, Infiniti with these hybrid vehicles, they are using Potch cells, for example. Yeah, These cells, I will make a little sidestep on the recycling process, because we always say, yeah, it's a shame how we build this Li-ion cells, and it's true, because we are using nickel, lithium, mangan, and cobalt, and all those things are coming from third world, let's say, and the conditions to get those materials are very bad. So to avoid that we are using this and we are dropping this in the trash once the cell is damaged, we have a kind of recycling process. There are two possibilities. The first possibility at all is when we take a full battery out with one broken cell, then we still have at least 1,000 other cells that something around 1,000 other cells that they are okay. So these battery modules are used in the second life circle. That means there are companies buying those battery modules from the car manufacturers, and they are building. I only know the German word is puffer battery. It's a kind of storage battery for home electric. So if you have for example, an electric system on your roof to get electrical energy, you can have a kind of storage battery which is used of old vehicle battery modules. When I say old vehicle battery modules, they are not broken. Something that we want to do is using those battery modules in another second-hand battery for vehicles. Why we are not doing that? Because in the vehicle, this module is stressed. It's very stressed. If I accelerate and if I brake, if I charge, I stress the battery cells and the modules. If I use that as a storage, as an energy storage for home use, this module and cells will not be stressed on the same level. It's a very low level of stress for them. Means that even if they are used from cars, we can use those things in buildings for years before they get any damaged, or before they are gonna get old at least. This is one thing. The other thing is we still have these broken cells. We take out a module or a battery which is damaged. We change it complete for the customer. 99% of the cell are used in a second life. And this last one is the broken cell. So now it was always like that. We shredding those, we dry it, we filter it. By filtering, we get a kind of black powder. And this black powder contains nickel, lithium, mangan, and cobalt. After a kind of air classification, we just take out from this shredded and dry stuff, we take out steel, separators, and aluminium and copper. The rest of the black powder is, at least not useful on the stand of today. Now there is a company that has invented a very big kind of machine, and they are doing a kind of hydrometallurgy. It's a chemical process. I don't exactly know how it works, but at least they are able to get those 4 components of the black powder out, so they can recycle it and reuse it again for new batteries and new cells. This is especially unique today. The problem is why it's not commercial. It's very easy to say, because the invest of energy to provide this hydrometallurgical process is so high that it's not the income at the end is too low, let's say. So now what we have to do is to work more and more on this process to get it more and more efficiency on it. And once this will be enough, so we maybe don't have to use new nickel, new lithium, new mangan, new cobalt, so we can use the old one. So that was the side step for the recycling process of electric vehicle batteries. If you are interested to see that source, on the right side on the bottom you see is dusenfeld.com. It's like Dusenfeld, like D Delta Uniform Echo, you should write it. And they explained this process, and there you can see the full system, how it works. And it's very interesting stuff. So it's very good to see that. Okay, let's come back to the HV system circle in a IT network. It means in our vehicles. Why an IT network? It's not IT like we know from computer systems. It's an IT means isolitaire, which means isolate against ground. And this IT system consists all that what you can see here. We have the inverter, we have the electrical engine, we have the battery, and sometimes we have air conditioning compressor, stuff like that. But the main system is written here. And as we can see, we have no connection to the battery ground of the body system. Battery ground of the body system is the point on the right side top, which is number 31. And on the downside, you see that only BMS has a similar system on the downside, BMS, but this is not connected. This BMS is battery management system. We talk here about the control unit, and the control unit for sure is working with 12 volt. But on the high voltage side, we have no connection to the ground system of the vehicle. One thing that we can see here is that we are, in the case that we have no high voltage, no low voltage, no 12 volt system, we don't have any high voltage as well, because if we follow the lines from 31 over 30, 30C, which is the 12 volt battery, then we have the ignition, then we have a fusee, and if we follow this line, we see that we have here kind of a relay, which is working on the orange line HV plus, and on the other side on the orange line HV minus. If we are not activating these relays, both of them, we cannot close the high voltage system. And so we can say if we don't have 12 volt on the vehicle, we cannot operate the high voltage system. This is something we need to know if a customer is calling us and he say, okay, my vehicle is not starting anymore. And the first question you need to ask him, do you have any ignition on it? Is there anything lighting up on the 12 volt system, on the dashboard or whatever? And if he says, no, it's still dark, then you can be sure that the 12 volt battery can be damaged as well. Okay, let's go further. I told you this is an IT system. It means to be sure that we are talking about an IT system, we have to control that. So insulation resistance test. The insulation resistance test is made by the vehicle itself, and we have some isolation guards in two different ways. We have IMD active and IMD passive. The difference is the measuring system. IMD active is the isolation guard, which is fitted somewhere on the vehicle. And we are doing this by an active test. This is something I always say we ping into the system like a sonar. And if we get no high voltage on the ground side, on the other side, if we don't have a voltage increasing, then we know that the system is working pretty much safe. On the battery unit, we have a passive system, which means that this system uses 3 voltmeters to ensure that we have always, this is a very, let's say, more precise measuring of the units. And this is only used in the battery itself. And we see here why, because we are measuring with 3 voltmeters between the line plus, high voltage plus, and PE, and between the voltage minus, high voltage minus, and PE, we have there 2 voltmeters, and we have a voltmeter between plus and minus directly. So if there is any difference on those voltmeters, so we see that we have a voltage drop, then the system alerts immediately that we have an isolation problem on the car. With having one isolation problem on the car will not stop immediately. A lot of time when I ask this, the technicians, and I say, okay, let's tell me what happened if we have an isolation failure on the car. They say, yeah, the vehicle stops. The vehicle stops. And that's not true, because this will have a kind of collateral damage. Let's say we are on a highway driving 120 and the vehicle is stopping suddenly, and behind of us there are a lot of other cars. we can create an accident, collateral damage, and we don't want this. So what happened? If I have an isolation problem on the plus line of high voltage, the system recognized that we have a isolation problem. It will get an alert lamp on the dashboard, tells you it will be an orange light, which tells you, please visit the next workshop. So this is nothing, that's not a big deal, because we don't have the opposite game player, which is here the ground. If you touch an open high voltage plus line and you touch on the same time the ground of the vehicle, you will not, that will happen, nothing will happen, because we have an isolated system. We don't have connection on the ground side. If we have an issue on the high voltage plus and a second issue on the high voltage minus side, let's say the customer is continuing driving and he don't go to the workshop, and why ever the second line is get damaged as well, we still don't stop the vehicle, because the collateral damage is still something we don't want. We will show the driver a red light now, telling him that once he stopped the vehicle, it will not be possible to restart it. So very easy. If the driver now drives to a shopping center, shopping mall, stops the vehicle on the parking ground, put the ignition off, surely he will have to call you to pick him up, because the vehicle will not restart again. For us, there is still no danger, because also the high voltage minus side is not connected to battery ground. The only danger that we can have now is to really touch high voltage plus and high voltage minus at the same time. But yeah, to be honest, I don't know if this can happen. On the other side, we need to check the isolation when we have the car in the workshop. At what time do we need to check the isolation? We have to always check it when we have disconnected the high voltage system and reconnected. Once we reconnect the high voltage system, we need to be sure that, before we reconnect the high voltage system, we need to be ensured that the IT system is working properly. How to control this? It's pretty much the same thing that you have on a water hose. Let's say we have a small damage on the isolation system. We need to have some high voltage load, some pressure, to ensure to see the drop out of electrical current. Same that we see on a water hose. If you put pressure on the water hose, you see that the pressure generates a small hole, and there the fluid is going through. And the same thing happened on the electric side. So it means if we have a 400 volt system, we need to put 400 volt minimum on the system to control if the system isolation is correct or not. If we use only 100 volt, we have not enough load to show the isolation failure maybe. To generate this load, we need a special tool. The requirement here is a mag ohm meter, because if you use a multimeter, you can do a resistance test as well, but you are not able to release 1000 volt or respective 400 volt with a multimeter. This tool here is able to generate up to 1000 volt. And once we measure this isolation, we need to have a result which is 100 ohm per volt DC or 500 ohm per volt AC. So let's say we have a 400 volt DC battery, then we need to have as a correct result by measuring the isolation 400 volt multiplied by 100 ohm. I don't know it's by heart, but it's a high number that occurs now. Yeah, do not use a multimeter. I think it's very clear why this will not function here. The measuring device that we have seen needs some time to put this pressure on the system, because we are talking here from even here a small battery that generates 1000 volt. And to generate this 1000 volt, we need a few seconds time. If you follow the green line here, you see that we are talking about round about 5-6 seconds that the current lead, the time that we need to build up this leakage current. If we stay under, so at least what I want to say is, if you put the leads from the measurement system on the car and you press test, don't stop the test after 2 seconds. Give the tool some time to adjust the right amount of power to be able to determine how or if the system is affected or not. All right, let's go to the next step, which is potential equalization. What is the potential equalization? The potential equalization is very easy. It's the kind of ground line that you have seen here. I told it PE line. The PE line is a ground connection between two different high voltage components. Means if I have let's say the electrical engine, and the outside of the housing from the electrical engine, we have two housing components, a left and a right side. And to be sure that on this left and right side, we don't have a different potential, we need to equalize these potentials. It means we need to screw it. On the engine is clear, we screw it together. By screwing it together, we have this potential equalization by the screws and over the housing. And if the housing is not screwed one by one, we need to put like the same like a ground cable from the outside of the housing from one point to the other to ensure that we don't have a different potential here. You all know a different potential means plus and minus. Because one potential is higher and one potential is lower. And if I have a potential difference, it means that I have a current running through. I did a calculation to show you a little bit how this potential equilibration is working. If you see on the left side, I was measuring the potential difference with 0.001 ohm. So it means 1 milliohm. And the result of my measuring, if I put a 500 volt battery on it and I put a shortcut on, is that on this shortcut, which will be a human body, we have 13 milliamperes, 0.013 amperes, that is going through the human body. Whereas the rest of the energy, goes through the battery, and there is a fuse which is breaking down. It's a very complicated system, and it's not easy to explain, and truly even on a few minutes on here on a webinar, it's not possible to explain that to you. But what you can trust me, and this is something that I will show you on the right side, if you just do a different measuring, the same conditions, but in a different measuring, and you measure the potential equilibration by 10 milliohms now, so 0.01 ohm, the result on the human body is 104 milliamperes. And as we have seen before, 104 milliamperes, and I show it to you again. Let's see on the left side, DC side, it's easier. Left side DC, and you see 100 milliampere. It's the end of the yellow of the second stage, means that you are already in next to stage 3, which can get some health issues for you. And if you go by 50 milliohms or something like that, you will increase already into the red zone. That's sure. The measurement of those potential equilibration, you can do it by a 4-wire measuring device, which is a very low-cost device. The only thing that we need to know is we need to have a test current, which is minimum 0.2 ampere. If we have, you can buy those devices as well with 0.1 ampere, but then it's not enough to do the measurement on the cars, because these tools are not only used by cars. So we need to have 0.2 ampere. Also here, we are not able to use a multimeter to do this measurement. because the multimeter has not this function. Very easy to say. Why I always compare that with the multimeter, if you are not, let's say, electrician or used to use all those tools, you can easily see, okay, it's looking like a multimeter. It is a multimeter, no? And just to say, no, it's not. Okay. 4-wire measuring. On 2 of those wires, we get 0.2 ampere, and on the other 2 wires, and we have the same clamps here, we have the possibility to measure the actual current resistance. Okay. Let's go for the last one, which is a special tool needed, the voltage absence test, voltage free. This is the tool that we have seen already in the beginning. We call this DUS-POL. And this DUS-POL, why we are not using a multimeter here? We just want to see if the voltage is absent or not. It means once we disconnect the vehicle, we are using this tool to ensure that we have no current anymore on the system. We can use a multimeter as well, but we all know if we are using a multimeter with a broken fusee inside, the result showing in the display will always be 0, even if we have a voltage on the system. And also, if we do a wrong regulation on the multimeter with a wrong measurement adjustment, we get a 0. And the correct level of let's say the correct amount of voltage that we want to see on a voltage absence test should be 0. So we're using this DUS-POL, which is a very cheap tool that you can get. We're using this DUS-POL because it's a very simple tool. It always shows the current which you have on the leads. So if you test on a 12-volt battery, it shows you 12 volt, and without doing any adjustment, if you put it on a power socket in your home, it will show you 200 and something. And you don't need to adjust anything. It's a very dumb and easy tool, and this is why we are using it. Coil resistors is the 4th measurement, just to get it sure that we have everything together. Here you can use a multimeter for sure. It's just a resistance measurement of, for example, the generator or something like that. Here, everything is fine with the multimeter. Okay, let's talk about the 5 rules of unlocking. Unlocking means disconnecting the vehicle. The first is disconnect. The second one is secure against restarting. It means we have to ensure that no one is restarting it. We have to put a padlock on it. Determine absence of voltage. This is the absence of voltage test. And point 4 and 5 is coming from the electric industry and has nothing to do with us on the cars. So as a S2 and even as an S3, we have not to earthing and short circuiting, and we don't have to cover of neighboring live parts. This is something that you use in the industry, but not on the car vehicle. So for us, it's the 1 and the 2nd and the 3rd point is a very important one. Means to start with the first one, disconnect the vehicle. What does it mean? At least when you put the ignition at 0, we already disconnect the vehicle. Remember what I told you, if we don't have 12 volt on the system, we don't have the relays closed, and if the relays are not closed, we cannot use the high voltage system. And the same thing happened here. So once I put the ignition at 0, technically I already has the shut down the high voltage system. But this is not the only thing that we need to do. It would be too easy. We have to control it, and we have to ensure that it's not only trusted in the ignition that what we do. So we have a few different possibilities. We have the possibility to disconnect the high voltage plug. The other possibility on the newer cars is disconnecting a low voltage disconnecting plug. The next step of evaluation is remove the fusee for the BMS system. And we have some switch off via diagnostic tester that we can do. And we have the rescue line that can be opened as well. And this is only for emergencies. This is nothing that you should do in the workshop. I tell you soon why. First, we have a look on the high voltage disconnecting system. I told you that once we take this plug off, we need to ensure that no one is putting the plug back on the car. So we have to replace it by a dummy. And this dummy is fitted with a special place to put a padlock in. So once this padlock is closed, you cannot reopen the switch. And you see here that this kind of switch can be different types of switch. They have this is only a small variation of it, but you can have a lot of more of them. So for us in the independent workshop, it's always difficult to have everything in the workshop, because one of those switches, of those dummies at least, costs like around about 100 to 150 euros. And yeah, if you want to have all the possibilities, you need to invest a lot of money. This is something that we find out that is not very simple to handle. This is why in the newer versions, we go away from this kind of disconnection plugs. I will show you this in detail here. You have on the downside, both on the left and on the right side, the high voltage pins. And this green bracket, which is around mounted over, is secured on the left side. Once again, there is the pilot line inside. I will show that later to you. So you have first to open the green bracket and then to pull out the orange connector. And then you replace this orange connector by the dummy, which is looking pretty much the same than this one. So only that we have the possibility to fit a padlock on it. The low voltage disconnecting is way easier because, sorry, I show you that once again. In this disconnecting, we are disconnecting the high voltage side straight. It means when we are using this one, we need to wear the rubber gloves and we need to wear the face mask. If we are not if you don't use those, we may, when we disconnect here, have a electric arc produced on the high voltage pins, which can lead to any issues on your skin. And if you see the second step, which is a newer one, which is disconnecting the low voltage plug, you see that the system is pretty much the same. On the downside, you see on the picture, you put out this red small thing, which is blocking the connector, and then you pull out the full connector, the black stuff from the green one, and inside you have a hole to put a padlock on, so you cannot reconnect it. The thing is, you see on the top screen, you see on the point number 1, it's in the trunk area, and there is no high voltage cable on this plug. It's only a 12-volt disconnecting line. So you only tell to the control unit that you want to disconnect now, and the control unit is doing the rest for you. The simple thing here is that you don't need to use face mask or rubber gloves, because we are not dealing here with the high voltage straight. And the other one that I told you is removing a fusee. Same thing here. We have in the fusee compartment somewhere on the car, we have a yellow flagged fusee. And this yellow flagged fusee, if you remove it, the system is shut down, pretty much the same thing that you see here on the green connector. We inform the control unit that we want to have it shut down now. The thing is how to ensure that no one is reconnected here, because you can fit any other fusee to reconnect the system. It's very simple. To restore the energy here, you need to use the diagnosis computer. If you don't have the diagnosis computer with the right let's say allowance for you to restore the energy, please don't pull out this fusee, because you will get a problem then. So please, before you pull it out, ensure that you are able with your diagnostic computer to restore the energy after it. Yes, the emergency line, in an emergency case, it means that let's say the fire workers come to an accident. They see on the accident, okay, we are talking about a high voltage car, so personal protection for them is the highest point, the ultimate point. So they firstly disconnect the high voltage system. And for them, it's easy. They don't want to search about the sockets or the connectors or whatever. They just have a look, where is the pilot line, and you see it's marked here on the passenger, for you on the driver's side. On the bonnet, and what happened, they just take out a big tool, they just cut in this line with the big tool. They don't care about the damage of the car, and they ensure that by cutting the pilot line in a millisecond, the system is shut down. The difference by shutting down by connector and shutting down by the pilot line is very easy. When you use the connector, you have some yeah, the English word, sorry. Give me a second. I have to search for the English word. Okay, you have some coils that store the energy in the system, in the vehicle, and if you use the connector, these coils are discharged very smooth and slowly. It means within a few seconds. If you use the pilot line, like it's mentioned here, the disconnection of these coils is in milliseconds, and to get this energy away, we are using resistance, and this resistance are fitted into the power unit and the battery power unit, which means if you're using this line a few times, this resistance will burn down. So at least you will have a malfunction later on the car. Yeah, the same pilot line you find through the, I will show you in the next slides. First, what should we do in Germany if we disconnect and we measure and we still, okay, we see, okay, we still have some high voltage on the system. Then we stop working when we have only 2S education, and we call someone that is 3S educated, and now we have to do at least kind of diagnosis on the tensity. So everything you need to follow is S3 for qualification needed. Put on personal protection, disconnect the plug somewhere near the battery, and actually here this will be a disconnection under current, and then carry out troubleshooting. The discharge time, this is what capacitor was the word I was missing, sorry. It was not coil, it's capacitor. The capacitor has a discharge time, and this discharge time from the switch off moment to the safety time will be around 10 minutes. It's way faster than this, yes, but to ensure that it's really enough time, we say we let 10 minutes ago before we measure the voltage absence on the car. We tried that once in a training center, and it was like done in something like 10 seconds. So we don't need 10 minutes. It's between 10 and 12 seconds. If you see the pilot line, HV interlock circuit, this is the red line that you see here on the schema. And you can see that we are crossing all the electric components, and we are on all connectors. Here, this is a connector, and the red line is going through all these connectors. If you are using the safety line, the interlock line, to disconnect, you will discharge the capacitors in 1.2 or 1.3 seconds of time. So it's very, very fast. This is what I mean when I say it's not controlled discharging of the capacitors. And this red line I told you is going across every parts, and you can see here, for example, the inverter of and Toyota. And even if you take the inverter cover down, you see here on the downside that they put the pilot line on it. So if you forget before to take to put the ignition off, to take the switch out and all the security stuff, at the moment that you take the cover off, you disconnect the pilot line, and to ensure that here around the capacitors will not have any current anymore. Okay, and to come back on the disconnecting system, you remember this high voltage disconnecting plug, the orange one with the green bracket. You see here the orange one, which is fitted on the high voltage side, and in the middle you see the 12-volt system, which is the pilot line going over. Sorry. Okay, here we go again, which is the pilot line. And you can see if if you disconnect, this plug, the first thing you will disconnect is the green bracket. As I said, you have to open the green bracket to pull the orange connector out. And by disconnecting the green bracket, you open the pilot line, because the pilot line is running through this green bracket. And at least if you forget the ignition, if you forget everything around here, you cut out the energy before open the high voltage line. Yes, if you want to know where is all those stuff fitted on the car, for example, and you don't have any access to OE or yeah, computer or whatever, you can use rescue cards. These are the rescue cards that are used by fire departments as well, or ambulance, someone like that. If they come to a broken vehicle, as I say, they will have these cards on board of their truck, and they will have a look into the card, and they will find the location of all the electric parts and the cables and the battery, and they also find the location of the emergency line that they can cut off. And here, especially, they will not do it if the car is not damaged from outside. If there is no accident, they will not cut holes in the car for sure. They will not break down the car, but they're using that only when there is an accident on the car. For you, it's very nice because you can find those rescue cards on the homepage of every car manufacturer. So you have a search field on the top, and you just put a rescue card in, and you get the rescue card of all vehicles from this manufacturer. Very nice to have if you don't have access to any other details. Let's talk a bit about the towing, because there is only one way to correctly tow on a vehicle. We showed up 2 ways here, but you can already see the correct way is to have, if you have a 4-wheel drive, or the electric driven wheels never have to touch ground. They don't have to turn when you tow the car. Means if you put it on a truck, all the wheels on the air, it's fine. If you have a front wheel drive and you tow it like on the second picture, is fine as well. If this will be a rear wheel drive and you lift up the front, it's not good, because then the electric driven wheels will turn on the ground. And same on the last picture, it's not good at all. So if you want to tow a car like that, please ensure that the electric driven wheels are not turning on the ground, because you are producing some energy. It's like a generator at this point, but the other side, the ignition is off. And if you have the generator and the electric is produced by the generator, and there is no control unit on the other side which is controlling the power, then you break down the system at least, and this will be very, very expensive. Yeah, towing in the event of a breakdown. If you get the car like that on your working place, that can be an accident happen, and you see that there is a big deformation, or there is a deformation on the battery side. Here, the system is safe because we seen the system has shut it down by the airbox. The airbags going up means that the high voltage system is shut down. But what can happen here? The battery cells are mechanically torqued, let's say, they are broken. And if you damage a cell mechanically, it means that you can produce inside the cell a kind of resistance, which means that the cell becomes hotter and hotter. And the increase of temperature is a big stuff, because if you have the core temperature over 60 degrees, 60 degrees Celsius, then you have a chemical process started into the cell. That means the car will burn down. You cannot stop this chemical burning process. You see that if you put on video on YouTube, if you search for electric cars burning, you will find a lot of YouTube videos, and this is exactly what happened. And if you see the fire compared to a wooden fire, it's something that you see, this is a kind of pressure burning, which has nothing to do with a normal fire. So to avoid this, if you get a car like that on your ground, do 2 different things. The first thing is, don't put it in your workshop, and put it away from everything around which can burn. So not the building and no cars next to it. And then you control the temperature of the battery, which means you have a ultraviolet temperature control that you use to see if the battery temperature from one day to the other increases. And Volkswagen, for example, the manufacturers, they say exactly how much increasing is allowed or not. And they say if the increase from one moment to the other is more than 3 degrees Celsius, you need to be careful and to handle the car on a special, to treat the car in a special way. Means you have two possibilities. The first one is you dismantle the battery. You are S3, you dismantle the battery and you put it in unified modules that are not dangerous anymore. And then you have no big battery problem anymore, no problem, no issue. Or then the other way is you put it in a container like that. And if the temperature increases more and the car starts to smoke because of the fire is going on, then at least you put water on this container. Don't do it immediately, because let's say if you have an insurance file here, the insurance will have a look on the car. If you put water on it, you damage the car by it all. If you have just a lightly damaged car that the temperature increases, just put it in the container and then you just wait. In Germany, we call the fire department. They have those kind of containers. They put the container on your ground. They put the car inside. And when you call them again and say, okay, now smoke is coming out of the car, then they come back again and they put water on it. So don't do it by your own. Yeah, temperature problem is as well an issue for the bodyworks. So if you have a paintwork done on the car, and you want to dry the paintwork very fast, you put it in a heat chamber. The manufacturer says how many time and how much degrees we allowed on the car to put on the heat chamber. So here is an example: 45 degrees, 45 minutes by something degrees. Please always have a look on the manufacturer's documents telling you how long and on what temperature you can put the car in the heating chamber when you have done some body works. Yeah, I talked a lot and I talked very fast to get the time done again, but it's 21:24, so yeah, I used almost everything. I'm ready. I'm finished on my